Separators for petroleum industry is pressurized vessels that are designed for separation inlet production fluids into their constituent components, such as oil, gas and water. Separators work on the principle that three components have different densities, that allow them to stratify when moving slowly with gas on the top, oil in the middle and water on the bottom. Separators are available for two-phase operation and three-phase operation. In two-phase separator, the gas is separated from the liquid. Separated gas and liquid are being discharged separately. In three-phase separator, inlet flow is separated in gas, oil and water. All separated components are being discharged separately. Any solid such as sand or other particles settle in the bottom of the separator. Oil and gas separators can have three general configurations: vertical, horizontal, and spherical. Horizontal separators are most efficient for normal oil-water separation, particularly where there may be problems with emulsions, foam, or high gas-liquid ratios. Vertical separators are most efficient for cases when the well streams have large liquid-to-gas ratios, constant flow, and small liquid surge characteristics, high gas, low liquid. Spherical separators are less efficient than either horizontal or vertical cylindrical separators and are seldom used. Nevertheless, their compact size and ease of transportation have made them suitable for some processing areas. For properly performing efficient job, separators have various internal elements. Those internal elements are being installed inside of the vessel and their design configuration is various depend on requirements are applied to separation process. Main purpose of separator internals is creating condition that allows separation process based on density differences among inlet flows components, proceeds most efficiently. There are many types of the separator's internals that are applied depend on complexity of required separation process. Together with that, some internals are commonly used in most separators. Those internals are followings. Inlet diverter. It changes the direction of flow by absorbing the momentum of the inlet flow and preventing splashing entering fluids into the main separator area where actual separation is performed. Wave breakers or baffle. It is used for stabilizing liquid movement inside the separator that can occur due to surges of inlet flow. Defoaming plates. It breaks up the foam and allows the foam to collapse into the liquid layer. Mist extractor or mist eliminator. It captures small liquid droplets from the gas, which goes through the mist extractor section before it leaves the vessel. Weir plate. It holds heavy liquid and allow light liquid, or oil, to skim over. This allows the next chamber to have only light liquid, or oil. Vortex breaker. It prevents a vortex effect on liquid outlet lines that could be cause of gas entering into liquid outlet lines. Sand jets. As it's been mentioned above, within oil-water-gas separation process, some sediments such as sand and other particles gradually accumulated on the separator bottom. Increasing of accumulated sediments volume negatively affect to separation process efficiency. For maintaining required quality of separation process, separators should be cleaned from those sediments. Separators cleaning can be done either by putting separators offline, isolating it, and manual cleaning, or online cleaning by using so-called sand jetting system, when separators cleaning is carrying out without the separator shut down. In this video, 3 phases horizontal separator shall be considered. This type of separator is widely used. 1. Needs to be noted that for properly performing its function, that following instrument devices and equipment should be installed on separator and its outlet line. Pressure transmitter or pressure indicator that measures gas pressure in the separator's gas section. Oil level indicator that measures oil level in the separated oil section. Water level indicator that measures water level in the separated water section. This level indicator shall be configured in that way that it doesn't react on common level change of water section level but reacts only on water level changes. Usually that achieves by selecting the indicator with level measuring floating elements is made from material heavier than oil but lighter than water. In this configuration level indicator measuring element drowns on oil but floats on oil-water interface and reacts once this interface level changes. Pressure controller that plays role of some logic by receiving input pressure indication signal from pressure transmitter and on base of its set logic, generates and sends output signal. Oil level controller that plays role of some logic by receiving input oil level indication signal from oil level transmitter and on base of its set logic, generates and sends output signal. Water level controller that plays role of some logic by receiving input water level indication signal from oil level transmitter and on base of its set logic, generates and sends output signal. Pressure control valve. This control valve on base of command is received from the separator's pressure controller, that in its turn uses input pressure change signal received from separator's pressure transmitter, by opening and closing, holds the separator pressure on certain set point. Oil level control valve. This control valve on base of command is received from the separator's oil level controller, that in its turn uses input level change signal received from separator's oil level transmitter, by opening and closing, holds the separator oil section level on certain set point. Water level control valve. This control valve on base of command is received from the separator's water level controller, that in its turn uses input level change signal received from separator's water level transmitter, by opening and closing, holds the separator water level on certain set point. Separator's pressure control carries out by this way. Within separation process, separated gas volumes inside the separator increases. As result of that the separator's pressure indication risers that forces pressure controller opens pressure control valve until pressure drops and returns to set point. By such way, separated gas releasing from the separator for ensure continuous gas separation process achieved. If pressure drops, and that happens if volume of separated gas reduces, pressure controller closes the pressure control valve until pressure rises and returns to set point. By the similar way oil level is supported in the separator's oil section. Within separation process, separated oil volumes inside the separator increases. As result of that the separator's oil level indication risers that forces oil level controller opens oil level control valve until oil level drops and returns to set point. By such way, separated oil releasing from the separator for ensure continuous oil separation process achieved. If the separator oil level drops, and that happens if volume of separated oil reduces, the oil level controller closes the oil level control valve until oil level rises and returns to set point. By the same way water level is supported in the separator's water section. In this case, exactly same functions provide separator's water level indicators, water level controller and water level control valve. By referring to information above, separation process on three-phase separator can be demonstrated as following. Oil-water-gas flow enters to the separator and passes through diverter that prevents splashing entering flow over the main separator section, then liquid flow passes wave breakers or baffle and is being stabilized that allows more efficient oil-water separation to take place. Separated water is accumulated on the lower level of the vessel. Within separation process is continuing and additional water volume is entering into the vessel, separated water level is rise. Exceeding water volume leaves the separators by control of the separator's water level control system as described previously. Vortex system on the separator's water outlet prevents vortex effect that can be caused either oil or gas entering to the water outlet line. Separated oil is accumulated on the middle level of the separator's main section and by skimming over where plate flows to the oil section of the vessel. Within continuing separation process, additional oil volume is entering into the vessel and separated oil level is rise. Exceeding oil volume leaves the separators by control of the separator's oil level control system as described previously. Vortex system on the vessel's oil outlet prevents vortex effect that can be caused gas entering to the oil outlet line. Separated gas passes through defoaming plates, that breaks up the foam and allows the foam to collapse into the liquid layer. Within continuing separation process additional gas volume is entering into the vessel, separated gas pressure is rise. Exceeding gas leaves the separators by control of the separator's pressure control system as described previously. Before leaving the separator, separated gas passes through mist extractor or mist eliminator, that captures small liquid droplets from the gas. Those droplets also are collapsed into the liquid layer. This is very typical oil-gas-water separation process description in three-phase separator. Depend on requirement is applied to level of oil, gas and water separation. Some additional equipment can be added to separators. For instance, additional volume can be installed on the separator's bottom or some other internals can be added for achieving better separation of oil, gas and water. All those are matter of engineering design that carries out depend on separator operator's requirement. Jetting system is used for sand and other sediment particles removal from the separator is not covered in this video. Sand cleaning operation by jetting system is periodically used operation, but not continuous one. Jetting system consists of not only equipment installed inside separator, but various equipment located outside the separator. Due to all those reasons, sand jetting system shall be covered by another video.